You are welcome again to Module 2, Unit 4 of Physics 115. In Unit 3, we have established the applications of the equations of motion in the horizontal plane. This unit presents the applications of the equation of motion along vertical axis. That is, the direction of motion is along a vertical y-axis instead of the x-axis. This concept is termed free fall motion. Having watched this video, you should be able to define free fall acceleration, describe free fall problems, then solve simple problems involving vertical motion. What is free fall acceleration? Let's have, if an object is thrown up or down, we eliminate the effect of air on the flight. The object accelerates downward at a certain constant rate. This rate is called the free fall acceleration, and its magnitude is represented by g. The value of g varies slightly with latitude and elevation. The value of g is taken to be 9.8 meters per second square. Let's describe free fall problem. Suppose an object is thrown upward with an initial positive velocity u. The acceleration a is equal to minus g, and by the time the object gets to its maximum height, the final velocity becomes 0. On the return of the object back to the ground, the final velocity u is 0. Acceleration a is plus g, and the final velocity has its value on hitting the ground surface. So let's recall the previous equation of motions that we have written. Then we can restate it, since we have assumed that since our a is equal to g under free fall acceleration, then we can write v is equal to u either plus or minus gt. You discover that a has been replaced by g, and the plus and minus sign is such that if the object is being tossed up, since the object is working against gravity, then g is minus, and if the object is falling down freely, then g is positive. Also, we have written s is equal to ut plus or minus half gt square. The only thing that is changing is the g that replaces acceleration a. Also, we have v square is equal to u square plus or minus 2gs. Then lastly, we have an s equal to 1/2 into bracket u plus or minus v into t. So let us use this equation to solve simple problem under free fall acceleration. Example 1. An object is released from a height above the ground. Obtain its final velocity after 5 seconds. Take g equal to 9.8 meters per second square. Solution. We have g equal to 9.8 meter per second square. Then we have time equal to 5 seconds. But you must be very careful, because the object is released from a height. That shows that that object is falling freely, and g is positive in that case. Then we can apply v equal to u plus gt. In this case, g is equal to plus. So by substitution, of course, since it is released from rest, u is equal to 0. So we have 0 plus 9.8 times 5, which is equal to 9.8 times 5, 9.8 times 5, which is 49. We have 49 meter per second. Let's see example 2. A stone is thrown vertically upward with an initial velocity of 40 meters per second. Calculate A. The velocity after 3 seconds, B. Maximum height attained and the time taken to reach it, C. The total time taken for the ball to return to the ground. This question is similar to the one we have just solved. Let's see the solution. A. So if a stone is thrown vertically upward, that shows that then G is equal to what? Is minus. Then our G is given to be 9.8 meter per second square. Then we have velocity, initial velocity U equal to 40 meter per second, and we have to calculate the velocity after 3 seconds. V, using V equal to U minus GT. Of course, the stone is thrown vertically upward. Then by substitution, we have 40 minus 9.8 times our time is 3 seconds, that is already given. T is equal to 3 seconds. So times 3 here, we have 40 times 40 minus 9.8 times 9.8 times 3, which is equal to, then we can say we have 40 minus 29.4, which is equal to 40 minus 29.4 equal to 10.6. So our velocity is equal to 10.6 meter per second. So let's solve B. The maximum height attained and the time taken to reach the maximum height. At the maximum height, we can use V square number B. Using V square, equal to U square minus 2 GX maximum. Okay, then our V for maximum, at maximum height, at S max, comma, V is always equal to 0. So 0 square will be equal to 40 square minus 2 times 9.8, then times X max. So make X max the subject of the formula. X max is equal to 40 square divided by 2 times 9.8. So let's calculate that. (40) square, which is equal to 1,600 upon 2 times 9.8 . $19.6. So the final computation gives us 1,600 divided by 19.6. That gives us 81.63. 81.63 meter. Then B, we are also asked to find the time it takes the stone or the particle to reach the maximum height. Of course, we use V equal to U minus GT. Then, having calculated our velocity, which is 0 at the maximum height, then we substitute 0 equal to the initial velocity is given as 40 minus 9.8 times t. Then we make t the subject of the formula. That implies that t equal to 40 divided by 9.8, and that gives us 40 divided by 9.8, which is equal to 4.08. .08 seconds. That is the time it takes the stone to reach maximum height. Now C asks that we should find the total time taken for the ball to reach the maximum height and comes back to the ground. C, we know that if it takes the ball to reach a maximum height here, this is our maximum height, and the time recorded is equal to 4.08 seconds. Okay, so if it takes the stone this time to reach maximum height, it will definitely take the same time for the stone to fall back to the ground. Therefore, the total time taken, for the ball to reach the ground is now equal to 2 times t, which is equal to 2 times 4.08, and that gives us 8.16 seconds. In conclusion, we can deduce that in free fall motion, acceleration is always constant, while acceleration varies in the case of horizontal motion. We shall meet again in the next class. Bye.